I'm going to talk about a method that we can use to sample channel catfish in reservoirs. So when we're talking about a standard method, what I'm talking about is using the same method that allows comparison of results. Standard methods have been critical to advances in science, industry, and medicine. When it comes to fisheries science and management, one of the biggest, if not the biggest steps in advancing standard methods was this book by Bonar, Huber, and Willis that proposed standard methods for sampling freshwater fish across North America. Includes the methods in this book sample channel catfish. The method that best samples channel catfish in this book is the gill net method. Another important advance in standard methods was this paper by Cook et al. In 2014. What they did was they actually evaluated these standard methods in Kansas reservoirs, mostly looking at precision and catch of these methods and estimated effort required to meet precision and catch objectives. So they did evaluate the gill net method for sampling channel catfish in these reservoirs, and they found that generally catch was low and precision was also low. So now, looking at standard versus standardized methods. When we're talking about standard methods, we're referring to the methods in the book that I just talked about. Standardized methods can meet any other local or otherwise standards. Basically, they're standardized, but they are not the proposed standard methods in the book. So Ohio has been using a standardized gill net method, which is specified by our inland management system, which is the framework for collecting, storing, and using fisheries data in Ohio. And like the standard gill net method, we had historically used this standardized gill net method to sample channel catfish. And we looked at our data much like the Cook et al. Paper, and also found low catch, low precision for channel catfish sampling, and this was especially evident in our small reservoirs. So what gear should we use to sample channel catfish in these reservoirs? Literature shows that the gear of choice is tandem baited hoop nets. So this is a tandem hoop net set. This was identified by the famous literature review by Boarding et al. They found that generally the literature showed that tandem baited hoop net sets result in high catch, and they recommended this gear. However, there's not been a proposed standard method for how to fish this gear. So, the objectives of a standard sampling method were proposed or described by this paper by Bonar and Hubert in 2002. These objectives were to minimize sampling variability, maximize catch, and have an estimate of the effort required to meet catch and precision objectives. So the overall goal of standard methods are to have indices that are comparable through time and space. So to meet these objectives, there are 4 major components of a standard method. The first component is the sampling target, such as the species and type of water body where you're sampling, the gear used to sample, the time period of sampling, and the amount of effort. So let's step through these components and see what we have, the information we have so far for sampling channel catfish in reservoirs. reservoirs. So we know that the sampling target is reservoir channel catfish. The gear is tandem baited hoop nets, which has been recommended in the literature, but we don't know if this gear truly does serve as a valid index of density. The time period in the literature has generally been summer, kind of, I guess, but a specified period has not been defined or proposed. The amount of effort, this has been looked into a little bit, and generally it's found to acceptable precision is achieved with around 20 tandem sets in a survey. So the objectives here of our analysis were to define a standard time period of sampling with tandem baited hoop nets, validate catch per unit effort as an index of density with this gear, and confirm the amount of effort that's required to meet precision and catch goals. The goal of this is to propose a standard method for sampling reservoir channel catfish populations. So to go about this, we used intensive Mark-Recapture methods that were carried out at 3 reservoirs. We estimated catch per unit effort over an extended study period that went from May to about August. So May through July. We looked at temporal changes from May through July, through the end of July. We then identified a time period using change point analysis. So this is an R package that identifies change points in time series data. So we use this to find the time period where catch per unit effort is highest across all 3 reservoirs. So then we estimated density with our Mark-Recapture surveys to confirm that catch per unit effort is related to density, or to validate it as an index of density. To do this, we used a resampling approach where we resampled our catch per unit effort from our recapture events and tested for differences in catch per unit effort among known differences in channel catfish densities. Okay, so the 3 reservoirs where we did our intensive Mark-Recapture approach were Dillon Reservoir, which is a large reservoir, it's called Dillon Lake, Burr Oak Lake, which is a medium reservoir, and Hargis Lake, which is a small reservoir. So we also used extensive methods to estimate the effort required to meet precision and catch goals. So a precision goal is a RSE of catch per unit effort of 25 or less, and the catch goal is we want to catch at least 100 stock length fish in a survey, and these are established metrics that have been used in the literature. They've been used in the Cook paper. We did this in 47 reservoirs across the state, where we estimated precision and catch of our tandem baited hoop net samples. We did this in the reservoir categories that were used in the Cook paper, where our small reservoirs were roughly less than 100 hectares, medium reservoirs 100 to 400 hectares, and large reservoirs were over 400, and the biggest reservoir that we used in our data set was almost 3,000 hectares. We then used a resample analysis where we resampled this extensive data to estimate how many samples were required to meet these precision and catch objectives, basically using the same methods as the Cook paper. So now let's look at some of our results. This is identifying a standard time period from our intensive Mark-Recapture data. These are our catch per unit effort over date from Dillon Reservoir. The points are the individual recapture dates The horizontal lines, you'll see there is a, anyway, you'll see that the first horizontal line that represents an early low catch per unit effort period, followed by a longer high catch per unit effort. Now this is for the next reservoir, Burr Oak Lake. We see the same pattern. The second, although catch per unit effort is lower, the high periods of high catch per unit effort coincide. And finally, our small reservoir, Hargis Lake, a little bit of a different pattern where we have an earlier period of high catch per unit effort that decreases. But we were able to find a period where the high catch per unit effort overlaps in all these reservoirs, which for our case here was the proposed standard period. And this was roughly mid-May to mid-June. Water temperature was 17 degrees to 28 degrees. So now let's look at our density estimates for these reservoirs. Big differences in absolute density or absolute abundance, and that gave us high density, medium density, and low density. So pretty big differences in density here. So this is what allowed us to validate catch per unit or investigate the validity of catch per unit effort as an index of density. So now let's look at the results of that resample exercise. So I'm going to show you catch per unit effort on the y-axis and density from our Mark-Recapture estimates on the x-axis. So here we have Burr Oak, Hargis, and Dillon. So the horizontal error bars are 95% confidence intervals in our density estimates. And the vertical error bars are one standard deviation of catch per unit effort. So we have low, medium, and high density. Our resample analysis showed that when we compare the lowest density and the highest density, we had statistically different catch per unit effort almost 100% of the time. However, when comparing low to medium density, we only found different catch per unit effort less than 20% of the time. And when comparing medium to high, we had different catch per unit effort about 50% of the time. So we see that catch per unit effort does index density, but as an index, it may be fairly limited by the effect size that you can detect. Now let's look at the required sample size to meet our precision and catch objectives. So precision, I'm going to show you on the y-axis, is the number of tandem net sets needed in a survey to have RSE of catch per unit effort of 25 or less. And on the x-axis, we're going to show you large, medium, and small reservoirs. I'm going to show you box plots. So that's our resample results. Now for the catch objective, the y-axis is the number of tandem hoop net sets needed to catch at least 100 stock length fish in a survey. Again, for large, medium, and small reservoirs. And this is the results of our analysis. So you remember we used in these surveys we used 20 tandem baited hoop net sets per survey. So that's this level of effort here. This is what we actually did. You can see in most of these cases, the objective was met. So 20 sets in a survey may provide a balance of logistical feasibility with meeting precision and catch objectives. So, to summarize, this is where we are right now in terms of a standard reservoir hoop net method. The sampling target is reservoir channel catfish. The gear we use is tandem baited hoop nets. The time period now, we have identified a 4-week period of mid-May to mid-June to use this gear. And it looks like we can get acceptable data with about 20 net sets per survey. So moving forward, we're not done yet. We'd like to continue to build this method. It would be useful to continue to sample more reservoirs over in different areas to collect data to continue to confirm the time period that we identified and the amount of effort needed to meet sampling goals, especially in larger reservoirs. So we don't really have very large reservoirs in Ohio to sample. We know that channel catfish fisheries are managed in much larger reservoirs. We think we need more work to better understand catch per unit effort as an index of density, because as you saw, our results suggested there's a pretty important, the effect size you're trying to affect is pretty important when it comes to the validity of catch per unit effort as an index of density. And continuing to build on this method will result in a rigorous method to collect channel catfish data for management in reservoirs in North America. So I'd just like to acknowledge the division, federal aid in sport fish restoration, and help from Ohio State's Aquatic Ecology Lab. And I will take questions. Yes.
Steve, do you think the precision goal of RSC at 25 is adequate for having statistical power to detect the effect sizes that you want to be able to detect?
I think it probably is. We looked at largemouth bass catch per unit, electrofishing catch per unit effort, which is generally, we have RSC of around 20 or so for a lot of those surveys, and we actually had, it was a lot, that survey that index was a lot more sensitive to density changes. So I think if you shoot for 25 or less, that provides reasonable data. Yeah.
Are you guys publishing in the proceedings from Catfish 2020 here?
Yeah, we just submitted the day before it was due.
Awesome. Well, it's interesting to see how you couch this. We're actually just beginning a rewrite of Bonar et al.
Right.
I would love to include this in that. I'm working on the warm, small standing waters, and I know the warm, large standing waters are going to be adopting that gear. The more information we can get before we set a standard would be good. And if anybody in the room has input on that, I would love to hear from you, just so that we can take all the best that we've got as we write the new gear spec for that.
Sounds good. Yes.
I missed the reservoir sizes, I'm sorry.
So the small reservoirs were 10 to 100 hectares, medium 100 to 400, large 400 plus. That's the same size categories used in the Cook paper.
Did you use 2 or 3 soak nights?
2 or 3 what?
Did you soak them for 2 or 3 nights? I didn't.
Oh, right. 2 nights.
2.
Yep.
Okay, thanks.
Thanks.